Okay, welcome back. Where is that window? Oh, that I was. Hmm. Okay. Okay. Let me to continue. Actually, after that, it is very easy. So as I told you, when you just make this order in ready queue, okay, the next thing is to execute them one after the other, like in first come, first served. And if there is any process that it is more than 4 nanoseconds, you have to put it to the end of at the end of the queue. So the next one is P1 will be PT3 will be execute 3 nanoseconds. Then P4 will be execute 4 nanoseconds, 1 nanosecond, sorry. And P5 will be execute 4 nanoseconds. And then one will be remains from 5 nanoseconds. And this will be sent to the end of the queue and continue to execute P1 1 nanosecond, P6 4 nanoseconds, and P2 2 nanoseconds. And at the end, the P5 last one 1 nanosecond, and finish the question. So like this. Where is P5? P4, okay. P6 4 nanoseconds. Okay. Okay, so the last one will be like this. Okay. Is it clear or not? I mean, who asked me this question? I told you that you can check the video of that Indian lady, and also you have this link. I mean, in the slides, I put this link to how to explain the round robin example, because while I am solving the question, I'm not doing like that because it needs so much space. And in the exam, don't do it like this. I mean, just updating the ready queue for each um, for each time. So what is pull job? job pool, you mean? It is the processes that are waiting in secondary memory. Someone asked me about what is a job pool. So extra sheet of papers is for friends. You don't need paper extra. Really, only thing that you have to make calculation for that scheduling algorithms, and you don't need extra papers. It is not economic class or mathematics class. It is just you will make some additions, a very simple division. Why you are thinking about this so much? Job pool is the pool of processes that are waiting in secondary memory to put to just load to primary memory. That is the name of the pool. Okay. So any other question?
Yes, sir.
Yes.
The arrival time and the burst time.
Yes.
When you are answering the round robin question,
Okay.
when the process 1 is 0 and the burst time is 2,
Okay.
and you have process 1, you have process 2 also, the arrival time is maybe 3 and the burst time, let me say the arrival time is 1 and maybe the burst time is 5. So how do you start with these processes? Am I going to choose process 1 to start with, which is process 0,
Okay.
and the burst time is 2?
Which one is arriving at time 0?
Yes, yes.
I mean, process 1 is arriving at time 0.
Yeah, process 1 has time 0 and
Okay.
the burst time is 2, and process 2 is arriving at time 1 and the burst time is 5.
Okay. So you have to execute CPU. You have to execute process 1. I mean, you told me that it is round robin. So let's say its burst time is 3 nanoseconds. So it doesn't matter if it is less. It will execute 2 nanoseconds process 1 and finish the execution. So no time is remain for that one, and start to execute the second one, process 2.
Hello, sir.
Is it okay or?
Yes, sir. Yes, yes.
Round robin is also a first come first serve.
I don't understand.
Yeah, when you are doing round robin,
Okay.
the time of the arrival time, which one come first?
The arrival time.
Yeah. When process 3 came, you have to execute it before getting another process.
Okay, are we talking about a specific question or? Sorry, I didn't get. I mean, you have a specific question that you confused, or If you have a sample, you can send to me. Hello. No answer.
Sir.
Yes.
Sir, can you hear me?
Yes, I can hear.
Hello?
Hello, I can hear.
Okay. Sir, okay, sir. Sir, can we try to solve some questions related to the quiz, please?
What did you ask?
Can we try to solve the quiz questions, if possible?
I mean, which one?
Let's try to solve all of it. It will be more understandable for us, if possible.
I mean, the
Especially the theoretical part.
okay. Sorry, your voice is just coming and going. Can you text to me to the messenger, please? I understand you want me
Yes.
to solve something, but
Yes,
I
sir.
will write.
Sir, he's asking if it's possible to
Right.
answer the quiz question that you gave, especially
I
for
mean,
that round robin
Of the quiz,
stuff.
yeah.
all of them. All of them, all of them for now.
Yeah, yeah. Yes, sir. Yes, sir.
Uh, um, actually, just 1 second. Okay, what can I say? Look, actually, all the questions are taken from the slides. So, for example, which one can be not found in the in the slides? No one. All of them you can find
Yes,
them
sir.
in the yes.
Sir, hello.
Hello.
Okay, there's no problem, sir.
Yes, I would prefer you answer question 11.
Answer question.
11, question 11.
Question 11. Yes.
Yes.
Don't tell me that it is okay. So look, if I answer it, you will not understand because I don't have a board to explain in detail. But which one you want me to explain? I mean the round robin or first come first serve or
Round robin.
Oh, it will take a lot of time. You are saying we are studying to your exam for tomorrow, and you have to study with us. Okay, just 1 second. I don't know how I can do it with an easy way. By the way, you have problem about solving this, or is it confusing, or you just want to be sure? Not this one.
We want to be sure, sir.
Okay.
It was very confusing.
Yes, and I told you I will not ask this much processes, but it is
Okay,
not
sir.
so.
Okay.
Okay, but I am
Okay.
going to solve it. Just 1 second.
Okay.
I'm
Thank you.
just trying to find the correct. I think it is this one. Oh, this one. Okay. Okay, time quantum is 3 units. So okay, let's draw my ready queue. I think I can write. Okay, this is my ready queue. And this is my Gantt chart. I'm going to, okay, I will draw it. Okay, look, it doesn't matter. The arrival times are in, it does not mean, it does not need to, arrival times will be in order, okay? So the first one, process 7 is arrived at 0. So process 7 arrived at time 0. And what is the burst time? Burst time is 4 nanoseconds. So CPU will execute this one first. That's how can I do it? I can make it as, just 1 second. And I can put it is not quitting from there. Let's put a table. Okay. And when time is 0 to 4, which process is executed? Process 7. Okay. So how much time it is executed? 4 nanoseconds. So when time is 4, which processes are arrived into the ready queue? Who can tell me?
Process 1 and process 6.
Okay, very good. So I can say, okay, these are executed. So process 1 and process 6, when time is 3 and when time is 4. Okay. So this one and this one. So just after P7, I will write process 1 and process 6. Okay. And this one is also finished execution. Let's do something for that. Let's make it like this. It is finished. Okay. Or let's make it red. Okay. So P1 and P6 are in the ready queue. I'm not going to put P7 back to the ready queue because we have 3 units of execution, so we have to put. Okay, so in this case, how much time remains? It was 4. Time quantum is 3 units. So I made a mistake here. Sorry, I thought that it is 3 units, 4 units, the time quantum. So it is executed for 3 nanoseconds. 1 nanosecond remains. So after that, here, P7 will be executed next. Okay, that's
Sure.
right here. 1 is remains to not to forget.
Sir,
Yes.
process 6 is not included here because the time quantum is 3. So it's only process 1 that is.
Yes, you are right. You are right. No, I for the first time I thought that time quantum is 4. Sorry. Yes, you are
okay.
right. Yes. So okay. So after 3 nanoseconds, only P1 is arrived to ready queue. So then I will put P7 to the after P1. Okay. So I put here 1 as to remember me that 1 nanosecond is remains. Okay. Just because of my capability is limited here to not like in writing to the board. Okay. So what is the next thing? Next thing, CPU will execute P1. How much time? 3 nanoseconds. So how can I do it? Okay. So CPU will execute P1 for 3 nanoseconds. So it will be 6. Yes. Now, because of P1, burst time is 3 nanoseconds as well. There is no remaining time. I mean, I don't need to put it back to the ready queue. But I have to consider which processes are came because CPU will, which processes are came when time is 6. So which processes are arrived? Process 0 arrived, process 5, and process
6.
Yes.
6 and 3.
Process 0 arrived, process 5, and process 3.
Yes.
Okay.
So and process 6 again. Process 6.
Yes, I heard you. Process 6. Process 6 is okay. Yes, you are right. Yes, between the time 3 and 6. First of all, which one is arrived? Process 6 is first.
6. Yes.
So I am forgetting that because in the beginning I thought that it is 4 nanoseconds of time quantum. That's why. So that's 1 second. Process 6 at time 4. Process 0.
4. Yes. Process 0. Yes.
Okay. Time is 5. If there is a kind of situation, I mean, they are arriving at the same time, just take them according to the process number. Okay. Order them according to the process number. So this one is first. This one is second. Process 5. Okay, and then which one is left? Process 3. Am I right?
Yes, yes. Process 3, yes.
Okay, process 3. So the next one is process 7 again, in this case. How much time? Process-
1 nanosecond.
Evet. Yes, only 1 nanosecond. Why it is not there? So it will execute only 1 nanosecond, process 7, and it will finish execution. Okay, this one is finished. So now let's check if there is any process that arrived at time 7. No process. Okay. This will arrive at 8. This will arrive at 12. So I can execute process 6. What is execution time of process 6 is 2 nanoseconds. So I will execute process 6, 2 nanoseconds. Okay, process 6. Then time is 9. So process 6 will not be put back to the
Process
ready
2.
queue. What? Yes, process 2 will arrive. Okay, but process 6 is finished. I don't need to put it back to the ready queue. So I will check for if there is any process when time is 9 arrived to the ready queue. Which one is arrived? Process 2 arrived when time is 8. So I will write process 2, okay? And I will execute process 0. Its burst time is again 2 nanoseconds. So let's add another cell. So process 0, 2 nanoseconds, time will be 11. Still, we have one process that didn't come yet. Then process 5. How much time? 8 nanoseconds. 8 nanoseconds, but we will do it for how much time? 4 nanoseconds. Because of our thing is time quantum. So I will put back process 5 to the ready queue, okay? But in this case, let's first check if there is any process arrived. Process 4 is arrived at time 12. So process 4 will be here. And then I will put process 5, and not to forget, we have 4 more nanoseconds to go. So then, which one was it here? Process 5. Okay, after that, after this one, all the processes are arrived. So I don't need to think about the table. I can just check this part and use first come first served algorithm. If there is any, by the way, I again made a mistake. No one warned me. Still, I made 4 nanoseconds here. So this should be 14. Yes, please. In the
14,
beginning,
yes.
and this one should be 5. Okay, P3 has 4 nanoseconds. So let me to add 4 nanoseconds more. Sorry, I'm saying 4, but I will execute 3 nanoseconds again. So 17. Here P3. What is execution time? Burst time is 4. So when I finished here, I have to put it back to the ready queue, but it has remaining 1 nanosecond. Okay. Then P2. P2 has 6 nanoseconds, but I have to execute 3 nanoseconds. P2, 3 nanoseconds, so it will be 20. Then I am erasing this, writing here P2. How much time it remains for P2? We had 6, we execute 3 of them, so remaining 3.
Remain.
Okay. P4 is 1 nanosecond. I don't need to put it back. It will execute and finish. Let's make it so only 1 nanosecond. 21. Okay, P4. Okay. P5 is 5 nanoseconds, so we have to put it back again. But I have to execute only 3 nanoseconds. So P5, I have to remove it from here and put it to the end of the queue. We have 2 nanoseconds left. So, okay, after this, you can clearly understand that only 1 nanosecond, 3 nanoseconds, and 2 nanoseconds left. So I can say you will execute P3, then P2, then P5. So this is not hard to understand. So I am just making them red, and I am adding 3 more. Why it is sometimes adding, sometimes not adding. Huh. Okay. Last one is okay. P3 is 1 nanosecond. So 25. And P3. P2 is 3 nanoseconds. Sorry, 3 nanoseconds. P2. And one more. And P5 is 2 nanoseconds. Okay, so as you see, I used ReadyQ to draw the Gantt chart. So the thing is here, you have to use both the table, time quantum, and ReadyQ. So actually this kind of examples are much more close to real, I mean, the computer system working. So I tried my best to solve the question. I hope you understood it. I have some chats. P4 burst time. Did I make a mistake? No, it is okay. Okay. So is it okay, this one? I mean, I recorded it. If you want, I can send it. I will send.
Yes, sir.
Is it okay, this one?
Yeah. You should please send the recording
Yes,
so we
sir.
can go over
Okay,
it.
I will send to WhatsApp, okay? Not to
Okay.
just the link to WhatsApp, not to Moodle.
Sir,
Yes,
All right.
I would like to ask something.
ask me.
Okay. You have to assume process 0 arrival time is 5. Burst time is 6. Okay. Now, it's an example I'm giving.
Okay,
Process 0 has arrival time 5, burst time 6.
okay,
Now, process 1 arrival time is 5, burst time is 2.
okay.
I want to I'm confused. That's why I want to understand. Process 1 arrival time is 5. Process 1
Okay, and first time?
is 2. First time 2, arrival time 5. Arrival time 5, sir.
Huh. Okay, what is confusing?
Okay, now here my question is are we going to choose the process due to the burst time or due to the process ID?
No, what did I say to you? It is a preemptive version of first come first served algorithm. So you will check the arrival times. If their arrival
Okay.
times are same, do not check the burst time. Just check the process ID.
ID. Okay.
Okay. Actually,
Okay.
it does not make so much difference because it is not make a kind of starvation if the first one is more burst time, because it is always making switching between the processes. So we have
Okay.
time quantum. So
Okay.
just I mean, order them according to the process ID
The
number.
process ID.
Yes.
Okay,
Okay.
thank you, sir.
Not at all. Friends, the meeting is finishing. I mean, do you have any other question?
Yes, sir.
Yes.
If the arrival time is higher than the burst time,
Okay.
are we still going to take the arrival time first? Because I can see we have the arrival time, the process 7 here, we have 0.
In round
And then
robin, in round robin, you are not checking the burst time. I mean, this is not your thing to check. You are checking arrival time. In shortest job first, you are checking the burst time. So
okay.
I never check the burst time if you see.